Okay, the first thing we're going to tackle here is the how many and how much type of problems, okay? These are the ones that I would say are relatively easy to handle, all right? Once you get the idea of it. So here we go. Again, these are these are accumulation type of problems where they give you a rate in and a rate out. So notice you have to kind of read the context here. We have these two equations, okay? But notice how it says the rate, right, at which people enter an amusement park. So notice how usually with the rate, that means the derivative, okay? It's tricky because notice how there's no derivative symbol here, okay? But they're telling you that that's a rate, so that's already a derivative there. Same thing, so this is the rate at which people are entering the park. That's why it's E of t. And then there's the rate at which people are leaving the park, which is why they call it L of t. But notice how these two are rates, okay? Pretty much how fast people are coming in and out, all right? So anytime you encounter a question where it says how many, what you have to do is you have to get rid of the rate. The moment I cross out this word rate, I'm talking about people entering the park, okay? So mathematically, to get rid of the rate, you have to integrate, okay? To get rid of a derivative, you have to integrate because they're inverses of each other. So look here, and again, do this on a separate sheet. If you want to know how many people enter the park, it only has to deal with E of t. It has nothing to do with people leaving the park. So if you want to find out how many people entered the park, you're going to have to integrate the rate, E of t. Okay? And E of t you could write explicitly. You could write 15,600 divided by that quantity. Or you could just write E of t. How many people have entered the park by 5 p.m.? Okay, so 5 p.m. So notice how for hours, they go from 9 to 23. So they're using military time here, okay? So we open at 9 in the morning. So I'm going to put 9 here. And then we want to know how many people have accumulated, have entered by 17 or 5 p.m. So you're going to put 17 right up here. And then you're going to plug and chug, okay? This is definitely a moment where you want to use Y1 and Y2, okay? So I would probably let Y1 represent this here, 15,600 divided by the parentheses quantity of t squared minus 24t plus 160, okay? Once you plug and chug there, you're going to get some value, but notice here how they actually ask you to round to the nearest whole number, okay? So, and that's it. Okay, let's take a look at the scoring guidelines. If I can find it. Okay. So take a look. We integrated, and then we got an answer. It's a plug and chug. There is no work in between, right? But notice how just with this one part, they give you 3 points, which is the bare minimum. So don't be intimidated by the length of these problems, because even if you only get one part out of the 4, you're in good standing to passing this exam, okay? Notice here how they gave you 1 point for the limits, which are the bounds, 1 point for the integrand, which is E of t. You could even use Y1 if you declared it, or you could just write this out explicitly, but who would want to do that because it takes longer, right? And then the answer, which is 6,004, they mentioned that you have to round it to the nearest whole, okay? So you get 1 point for the answer. So notice how that's 3 points already, okay? Cool. So let's do another one. Okay. 2003B. Make sure that you guys are labeling these here, okay? Here you're dealing with 2 rates. And in this case, we're not dealing with people at an amusement park. We're dealing with oil that's being pumped into the tank and then oil that's being removed from the tank, right? So hopefully you guys see the similarity here. So this is the heating oil that's going into the tank, and this is the oil that's going out. But more importantly, that these are two rates, okay? Rates. So they're derivatives there, okay? Okay, so here we go. How many gallons of heating oil are pumped into the tank? Okay, so we only care about the oil that's being pumped into the tank. All right, so here you would have to get rid of the rate, and the way you do that is you integrate h of t dt, and it tells you from 0 to 12. It's that easy. You just got to set it up. Now here you better make sure that you type it in correctly for y1 here. I would definitely not try to write this out on your calculator because most likely you will run into some type of syntax error, okay? You plug it in there. Notice how this says how many gallons, but it doesn't say how to round here, right? But pretty much you have your answer. Pretty straightforward. You wouldn't integrate R of T because that's the rate at which oil is being removed. So you got to pay attention to what they're asking for, okay? So here we go. If we go to that problem, this one here, not that far off. It's a 2-pointer. 1 point for the integral, which is the whole thing, including the bounds, okay? And then 1 point for the answer, whether you rounded correctly or not, okay? Still 2 points and 3 points, close to what you need, okay? Okay, so this is one problem that I want to go over because this really sets the tone on how well you understand the problem, okay? Take a look at part C, okay? So 3 things are always happening, okay, in these accumulation problems. You have an amount that you start with. You have a rate at which things are going in, and then you have a rate at which things are going out, okay? In part A, we're wondering how many gallons are being pumped into the tank. So to make sense of this, we don't care about how much oil is leaving the tank, and we don't care how much oil we started out with because we're focusing purely on how much oil are being pumped into the tank. So now let's take a look at part C, okay? How many gallons of heating oil are in the tank at t equals 12 hours? So exactly at the 12-hour mark, how much oil is in the tank? So I ask you guys, okay, and make sure that you pause so you can think about it. The question is, do we have to consider how much we start out with, how much is going in, and how much is going out? Okay, think about out of those 3, which ones do we have to consider based on the phrasing of this question. It says, how many gallons of heating oil are in the tank? So what do we have to consider? Pause there, press play when you're ready. If you're trying to find out how much oil is in the tank, you have to know what you start out with, how much oil is already in the tank. And you have to know how much oil is going in, and you have to know how much oil is leaving. So you have to consider all 3 here, okay? So at the beginning, at time equals 0, how much did we start out with? Okay, so if you read it, it says it right there. At t equals 0, we already have 125 gallons, okay? So we're going to have 125 plus. Now we got to consider, well, how much is going in, right? So we already figured that out. When we integrated h from 0 to 12, that's a total of how much is going in, okay? But then we also have to consider how much is going out. So when oil is going out of the tank, we have to take it away. So we have to subtract the integral of all the oil that's being removed. So we have to integrate the rate of removal, which is R of t here, from 0 to 12. So again, this is how much you started out with. This is how much has entered, and this is how much that has been removed. So if you consider all three situations, this will represent the amount you have in the tank at t equals 12. Okay, you will see a lot of this, which is why I'm going over it. Okay, you plug and chug, you get your answer there. If you take a look at part C, and this is where I'll end it. If I can find it. This is a 3-point question here, okay? A lot of points. You get a point for the limit, which are the bounds from 0 to 12. You get a point for the integrand. Now here they smush the two integrals together because they have the same bounds. If you write it separately, that's fine too. And they give you 1 point for the answer. Obviously, the answer includes how much you started out with, which is where you're awarded the 3rd point, okay? Focus on that one. Focus on knowing exactly what they're asking for, okay? Okay, here's some more practice just to make sure that we're all on the same page here, okay? We're in 2005. Part B here says how many gallons of water are in the tank? Okay, so think about that. In the tank. So do we have to consider what we start out with, what goes in, and what goes out? Okay, so if you're wondering how many gallons of water are in the tank, what do you have to consider? So the answer is you have to consider all three. If you want to know how much water is in the tank at a specific moment, you have to consider what you started out with. So at the very beginning, you had 1,200 gallons of water, okay? And to figure out how much is going in, we're going to integrate the rate at which water is being pumped into the tank. So we're going to integrate W from 0 all the way up to where we want to stop, 18, okay? And we also have to consider how much water is being removed. So we're going to subtract out the integral of R of t from 0 to 18. And again, you could smush these two integrals together. That's fine. And then you get your answer there, okay? But the biggest component is knowing when you need all three, the start, the in, and the out, okay? Here's another one. Here we're talking about sand that's being removed, the rate, right? And sand that's being added, okay? So in part A here, how much sand will the tide remove from the beach during the 6-hour period? Think about this here, pause if you need to, and then press play when you're ready. So if you're trying to consider how much sand the tide will remove, do we have to consider the start of the in and the out? So in this case, if you're just trying to figure out how much sand is being removed, it does not matter what you start out with, and it does not matter how much is going in. We're focusing purely on how much is being removed, okay? So we're just going to integrate from 0 to 6 because it's a 6-hour period. And we're going to use the integral of the rate at which is being removed, so R of t here. And then you plug and chug and you get your answer. Okay, let's do one more. Go ahead and try this one here with traffic flow. How many cars pass through the intersection over the 30-minute period? Okay, so in this case, there is just traffic flow. There's not really cars entering or leaving. It's just passing through the intersection, okay? So in this case, it would just be the integral of f from 0 to 30, okay? So if you notice, it's not that bad. It's just set up and answer. Your calculator does all the work. You really just have to piece everything together there, all right? I'm not going to do all of them, but hopefully that was enough practice for you to kind of get the hang of it.